it's me, Michelle from Lab Beauty Science. I'm a chemistry PhD graduate who loves skincare science, and today I'm going to be telling you about how micellar water works. Micellar water is a type of cleanser that's super popular with makeup artists and beauty addicts. The most famous micellar water is probably Bioderma's Sensor Bio H2O. Apparently, one bottle of this is sold every 5 seconds worldwide. A quick chemistry side note, it's H2O as in the letter O, not the number 0. This is a pet peeve of mine as a chemist because H2O is the molecular formula for water. What this means is that there are 2 hydrogen atoms bonded to 1 oxygen atom, so we have 2 H's and 1 O. H20 would mean that there are 20 hydrogens bonded together, which just doesn't happen, except maybe once in a star somewhere. Anyway, back to micellar water. Micellar waters are cleansers that you pour onto a cotton pad, then wipe over your skin. You don't need to rinse them after you use them, so it's almost like makeup wipe liquid in a bottle. How do they work? We're going to have to talk about the physical chemistry of surfactants to understand what's going on. The key ingredients in micellar water are a surfactant or multiple surfactants and water. Oil and water usually repel each other, and oil won't dissolve in water or vice versa, which is why you can't wash an oily dish with plain water. This is because oil is nonpolar and water is polar. It's like oil is Velcro, but water is a magnet. They just don't work together. This is a chemical principle that's commonly known as like dissolves like, which means that oil and water don't form sticky interactions with each other. But if you add surfactants to the mix, that's a different story. Surfactants are nifty little molecules that have 2 halves, a hydrophilic head that's attracted to water and repels oil, and a hydrophobic or lipophilic half that's attracted to oils and grease and repels water. It's like you've sticky taped a magnet to Velcro. Now everything can stick together in a big happy heap. In chemistry, this happy mixture is called an emulsion. Because getting oil and water to hang out together happily is really handy, you'll find surfactants in lots of products: soaps, shampoos, dishwashing detergents, laundry powders, moisturizers, foundations, mayonnaise, milk, ice cream, and of course, micellar water. For example, with an oily dish, the surfactants in the detergent can sink into the oil. Then when you scrub the dish, the surfactants break up the oil into droplets. Since the surfactants hang out at the surface between oil and water, they sort of hide the oil from the water. It's like it smuggles the oil into the water, so you can wash it away. It's the same idea with mayonnaise. Oil and vinegar usually don't mix, but if you have lecithin from egg yolk as an emulsifier or surfactant, it can smuggle in droplets of oil into the vinegar, and they stay together as a thick, creamy, delicious goop. When you use micellar water, you pour the product onto a cotton pad. Cotton is made of cellulose, which is polar, so the hydrophilic heads are going to stick to the cotton like magnets, and the hydrophobic tails are going to stick out on the surface of the pad like Velcro. And guess what? Makeup and oils and grease are non-polar, so they're like Velcro as well. So when you wipe the pad over your skin, the tails will grab the makeup and oils and grease, so you end up with clean skin. You might be wondering when I'm going to start talking about micelles. Micelles aren't actually that important to how micellar water works. When you add a surfactant to water, like if you mix dishwashing detergent with tap water, you have the hydrophilic heads and the hydrophobic tails of the surfactants and a bunch of water. Since the hydrophobic tails don't like water and the hydrophilic heads do, the surfactant molecules are going to arrange themselves or self-assemble so that the tails aren't touching the water. They can do this in 2 ways. The tails can stick out of the water into the air at the surface, sort of like ostriches burying their heads into the sand, or they can arrange themselves into little balls with the heads at the surface and the tails on the inside, sort of like tiny pincushions. These little balls are called micelles. Any surfactant in water will form micelles. The main difference with micellar water is that it's formulated so that the surfactants aren't as damaging to your skin as a standard rinse-off cleanser. Unfortunately, since surfactants are sticky, they tend to stick to things in your skin, such as proteins, which changes the structure of your skin. Since your skin's main role is to act as a barrier to keep water in and unwanted germs and chemicals out, this means that you can end up with a leaky barrier. Micellar waters are made so that the surfactants won't do this as much as a standard rinse-off cleanser. For example, they tend to contain gentler surfactants than a regular cleanser. They're also sometimes formulated with moisturizing ingredients like fatty acid esters to keep the skin barrier intact. But for some people who have sensitive skin, even micellar water might be too much. So if you find that your skin is dry or itchy or tight after you use micellar water, you can try wiping it off or rinsing it off with a wet towel or just water. So that's how micellar water works. I hope you found this video useful. If you liked it, please subscribe to my channel, check out my blog, follow me on Instagram, send me cake, send me science memes. And I'll see you next time for more beauty science.